Hi, good morning. My name is Xiao. I'm from Intel. My topic is about, sorry? Sorry, how to turn it back to my main page? Oh, cool. My topic is vDPA software assisted Llama migration. Oh, God. This is my agenda. First, I will give you guys some basic introduction on vDPA and talk about device Llama migration. And then we will have a quick look at how vDPA supports that. And then we will go into details about this topic, vDPA software assisted Llama migration. Okay, so what is vDPA? vDPA is short for vhost data path acceleration. It is used to make a software framework for without hardware acceleration. It can build a pass-thru like. Oh. Hello. It's a framework used for without hardware acceleration. It can build a pass-thru like data path within a para-virtualization framework. So as you can see in the diagram, the without device is still emulated by a hypervisor, but for the data path, the device can interact with the driver directly. It can DMA to the guest, and it can send an interrupt to the guest, and the guest driver can notify the hardware without any software help. So the vDPA technically decouples without into control path and data path. Here, the control path refers to device emulation and configuration, and the data path refers to the ring DMA operation and interrupt, doorbell kick, etc. And for the control path, vDPA remains control path implemented in software layer. And for the data path, vDPA moves it to hardware. And by this way, vDPA presents to the guest with a standard volatile interface. And the hardware acceleration is transparent to the guest. So this way, we build a unified interface for the guest. And this way is cloud-ready way of hardware acceleration. With ongoing without 1.1, so I think vDPA would get more performance, since without 1.1 will bring a more efficient ring, which is very great for the hardware. Okay, let's come to the question, how to line migrate a VM with hardware resource assigned. So to line migrate a VM with hardware attached to it, we need to address two issues. One is how to trigger the dirty page logging for the guest page that is written by the device. And the second one is how to migrate the device state from the source to the destination. So to line migrate a VM with pass-thru device, the problem is the hypervisor does not understand the device at all. So there is no standard interface between the hypervisor and the device. So the hypervisor has no interface to trigger the device to start logging, and the hypervisor has no interface to collect the device internal status from the source to the destination. So to do that, we have to hack the hypervisor and the guest. This is not friendly for the real cloud environment. So to address this issue, we come up with a workaround. Now we have pass route to the guest. We also have a without interface attached to it. In the guest, we make something like bonding, either by user space or either make a bond at the driver level. So with this bonding, when Llama migration starts, the hypervisor just unplugs the pass-through device from the guest, and then all the traffic will fail over to the virtual interface. So this way, we also have some requirement to the guest. We need the guest to do a bonding for Llama migration. So besides, we also require the guest to install a vendor-specific driver for the pass-through device. For the vDPA mode, because vDPA still follows the para-virtualization framework, the virtual device is still emulated by the hypervisor. So hypervisor can help to record the device state, because for each driver configuration, it will be trapped to hypervisor. Then hypervisor will get to know what the driver wants to do. So it knows exactly how many queues are being used and what features is being configured onto the device. For the third-party logging, hypervisor has a vhost channel to the backend. It can send vhost message to the backend to say, hi, please help to track the dirty page for each guest memory you write. And vDPA present a unified and standard virtual interface to the guest, so there is zero requirement to the guest kernel and the user space. One interesting thing about the vDPA Llama migration is you can do a cross-backend Llama migration. That is to say, you can Llama migrate a VM with software vhost. Either it's a vhost kernel or it's a vhost user to a new platform with hardware acceleration. Let's see how vDPA supports Llama migration and what the workflow is like. So when the user issues a migrate command, the hypervisor, let's say QEMU, will create a piece of log memory and use this log memory as a page bitmap for each of the guest page. And at the beginning, hypervisor, let's make it QEMU. QEMU will mark all the guest pages as dirty in the page bitmap, and then QEMU will share the log memory to the vhost. Then vDPA driver will configure the log memory information onto the device to trigger a dirty page logging. Then we come to the stage 2. For stage 2, each packet goes into the guest memory will cause the device to to do a dirty page logging DMA request to the page bitmap. And on the same time, QEMU will keep copying the dirty page from the source to the destination. And after a period of time, QEMU will find that, okay, there is only a small number of unsynced pages, so it decides to pend the VM and stop the vhost. It sends a message of get VM back to the host backend to collect some hardware internal index, and then it will try its best to synchronize the remaining dirty page to the destination site. On the destination site, all the RAM memory are recovered, and all the device internal states are restored onto the new hardware, and the network traffic can resume on the new network location. So as you can see, for the hardware logging way of vDPA Llama migration, we have a requirement for the hardware to include a logging function besides the basic variant DMA block. So here comes a question: how to Llama migrate hardware without third-party logging capability? Let's see how it works. Here you see the device is in direct I/O mode with the guest. And again, we want to do a Llama migration. So QEMU will allocate a log memory and shares to the host side. But this time, the driver will find that the hardware has no that logging capability, so we decide to use a software fallback way. First, we will unset the EPT mapping to unset the direct I/O mode. And then we try to set up relay software. Here, we set up a immediate variant. This immediate variant consists of descriptors from the guest and a new available ring, and a new user ring, and reconfigures the device. So in this case, the device can access the descriptor from the guest directly, but for the available ring and the user ring, it can just access the immediate variant. And we will have a relay thread set up for synchronizing the variant from the guest and the variant from the immediate layer. For each update on the guest, due to driver update some requests into the variant, the relay thread will copy that newly updated available ring entries to the immediate layer. And for each user ring update from the device side, the relay thread will copy that updated user ring entries from the immediate layer to the guest. For the page logging, because now we have a immediate software layer standing between the hardware and the guest, the software can have a chance to help the device to do dirty page logging. Let's see how this is implemented, because we want to set up a software relay model which is power efficient. So we make it as in an event-driven working model. So the relay is something like a epoll on the guest kick and the device user space interrupt. It listens, it epolls on these interrupt FDs, and when either the guest driver do a kick or the device issues interrupt to the user space, the relay thread will get noticed, and then it will figure out what the event is. If this event is a guest driver kick, the relay driver will copy the available ring from the guest to the immediate, and then relay the kick onto the device doorbell registers. If this event is a device interrupt, the relay thread will copy the user ring to the user ring in the guest and inject an interrupt into the guest. So when this user ring update is for a receive queue, then the software will help the device to mark that page as dirty for the corresponding receive buffer. And you may have a question. So the user ring update in the guest is also a guest memory write, right? So why not do the third page logging for that user ring? Here we want to do optimization. Since you know that the user ring is located at a fixed address in the guest memory, and the third page logging operation itself is very costly because it's an atomic operation. So adding an atomic operation in the data path is very expensive. So we delayed the user ring logging until the last second before stopping the device. And due to this, relay is in an event-driven working model. So when the guest network throughput is very low, the relay thread will consume very little CPU resource. But when the throughput goes high, the CPU resource of the relay thread will also goes up. To set up this kind of relay model, we introduced some new APIs. Now we have APIs to enable or disable the vDPA direct I/O mode. And we also have API to update the I/O memory table to control the device DMA scope. As you can see in the diagram, now we need to add a immediate vRing into the device DMA scope. Also, we have APIs for the available ring relay and new API for the user ring relay. Okay, let's see how the hardware logging compares to software logging. In the hardware logging mode, we have extra requirements to the hardware design guides. So we need an extra logging function besides the basic variant DMA block. And because the logging DMA is at a byte level, so all the logging DMA requests are small PCIe transaction or other kind of small bus transaction. But the hardware logging does have its advantage in terms of performance. So the CPU cycles never involved in the data path. And the hardware logging can provide a very consistent performance for the guest, even for a Llama migration stage. But okay, on the contrary, the software logging gets rid of this hardware requirement of logging, but it has some trade-off of CPU usage. And you know that when the network throughput goes very high, the rest rate will also be very busy. In my preliminary test, I observed a peak CPU usage of 40%. And due to more stuff involved in the data path, so the throughput of a network TCP stream fall off about 28% from the direct I/O mode. And since this new relay is a software fallback from the direct I/O mode, there is a very short network downtime for this switchover. And to improve the relay mode performance, we may try to combine adaptive polling mode with the event-driven relay. Okay, the overall vDPA upstreaming state is going very well. And for this vDPA software-assisted Llama migration feature, I have sent the V1 patch targeting at 1902 release. And for kernel specs, we also have a vDPA design. The Linux kernel patch and the QEMU part patch has already been sent to the community. Is in update state. And if you want to look at the basic vDPA framework and the Java implementation, you can download the latest QEMU and the DPDK repo to look for that. Like device model and the vhost user extension, etc. Okay, let's have a key takeaway. So, if vDPA enables a para-virtualization interface with a device pass-through grade performance, if you want to accelerate virtio or any other kind of para-virtualization interface with hardware, the vDPA notion will be very helpful. Can help a lot. You can understand vDPA notion and have a try on it. Here you may ask a question: what if I don't have a hardware that is very compatible? So what can I do to have a try? Here I have a suggestion. If you since that we can have without device emulated by QEMU or any other hypervisor. So you can use emulated without device and use it as a vhost hardware acceleration device. And if you are setting up a vDPA with a hardware that has no dirty page logging capability, so now we have a new facility. We can try this software-assisted line migration to fix the gap. Okay. So any questions from the audience? Since we have about 10 minutes for discussion. That guy is the first one.
I was telling you there are questions over here.
Great. So from here?
Hi, I'm Hideki from Japan. And is it correct understanding that I'm a DPDK application developer? So my question is that if the application developer have to be aware of the existence of vDPA or not?
Sorry?
I understand that your presentation explains about the framework to smoothly migrate VM from source to destination, right?
Yeah.
And because I am a DPDK application programmer, so my question is that if application programmer like me does have to be aware of the existence of vDPA or not?
vDPA is used for hardware acceleration of the virtualized para-virtualization interface, right? So if you are using the pure CPU resource to do network acceleration, so there is no hardware acceleration, right? So vDPA is not about that. But if you are setting up new hardware acceleration, like you are doing OVS hardware acceleration by some FJ or ASIC, etc., you have to consider about how to use hardware to accelerate the vhost or some other kind of para-virtualized interface, right? So you have to consider the interface. So vDPA is about using hardware to accelerate a standard para-virtualized interface. If you are looking at this scenario, so vDPA will help you. Yeah.
Okay, thank you.
Hi.
Hi.
So I don't think if I have understood this software fallback for the virtual VM migration, because if I understand that's right, is the packets are going to go to the vhost and then to the NIC.
Yeah.
So what's the point of having virtual?
What's the point of?
Yeah, because you are going to have packets going. So the point of vDPA is packets going straight to the NIC. If you have packets going to the vhost, and then from the vhost to the NIC, because you want to have, I don't see the point.
Okay, here we only, there is a immediate software layer in between the hardware and the guest, right? So this software layer is not the traditional vhost. You know that the traditional vhost copies the packet from the guest and into its own memory, and then it gives this packet to the NIC polymer driver, like calling the text burst or as burst, right? But this new software-assisted line migration only add a very simple and thin software layer. It just set up a new immediate variant, and it doesn't need to pass the descriptors of the guest, and the hardware can access the packet from the VM directly.
So
We just
the descriptor strings are going to be used by the vhost. The packets are going to be copied from the VM to the NIC.
Yeah, actually, this software relay is just an event relay. It's not it's not a packet copy and send it to the NIC. There is no packet relay.
Okay.
Yeah.
Okay. And the second question is this dirty paging logging. You say small transactions. Does it mean that the hardware is sending information about the dirty pages during the? So there's two options. The vhost asking the NIC, okay, tell me now how which are the pages that are dirty, or the hardware saying telling the vhost. So you say small transactions. Doesn't mean that is the hardware giving the information in small pieces to the vhost.
The new vhost just release has an agent viewing for the guest. For the packet and descriptors, it reduces the descriptor and the packet from the guest. So the hardware can directly send the packet to the guest memory.
No. I'm talking about just for the VM migration. You need to know which are the pages that the packets going to the VM are touched by the hardware. This logging that you have, not about the packets, but about the information that the hypervisor needs for doing the VM migration. That information from the hardware to the hypervisor, how is that managed? Is the hardware sending the information?
It's, for the hardware information, right? Are you referring to the hardware internal state?
The page, the dirty pages that. Yeah.
Okay.
So that logging. No, go another one. Another one.
Next one.
Yeah, that logging that you said here.
Yeah.
From the hardware to the hypervisor. You say there are small transactions. Does it mean that information from the hardware is how that is being managed? Is the hardware telling the information, or is the hypervisor saying, okay, give me now all the information about the pages that are dirty?
For the logging, it's a logging memory allocated from the hypervisor, right? And so the vDPA driver just configures that logging memory's information onto the hardware.
Yeah.
And so for every packet the hardware sends directly to the guest, it will trigger a dirty page login DMA write onto the login buffer.
Okay. I don't see that being
okay.
efficient, but
Okay. We can talk offline.
Okay, thank you.
So any more questions?
Yes, please. I'm Ronnie from Mellanox, Ronnie Frime. Did you try to use the IOMMU in order to collect all the dirty pages?
IOMMU, because so currently the IOMMU does not support to help the DMA do dirty page tracking, right? So here I use IOMMU to help the device do address translation, so the address can directly access the guest memories with IOVE, not physical address. So there is no address translation between the hardware and the guest. We just use the address from the descriptor and the hardware will DMA with this address directly.
Okay, so because we saw some patches that was running in a mailing, not in the DPDK mailing list, that's more in the storage things, that showed how to use the IOMMU in order to collect the dirty pages. So,
oh, really?
Yeah.
I think think that the idea of vDPA, or at least as I first knew about it, is that Intel is going to modify the IOMU hardware for giving that information, but probably that is going to be in the long term. So I guess this solution is until the IOMU hardware has this functionality.
Okay.
Is that right? Or
Yeah. So IOMU just helps the device to address translation for a DMA read or DMA write. It's not for third-party logging.
Okay, so maybe we can take the question offline.
Yeah.
Yep. Great, thank you. Thanks, speaker.
Thanks.